All right, here is 6.4.1. We're going to pivot a little bit away from the Pythagorean theorem and its implications for its converse and think a little more clearly about some specific types of triangles. First, we're going to deal with 45, 45, 90s in this screencast. We'll move to 30, 60, 90s, and then we'll broaden it so that we can think about any kind of right triangle. So in this one, this is pretty straightforward in a way. We have a 45, 45, 90 triangle, and what I've done is I've created it so that it's always the same. And you can see that this is an isosceles right triangle. Not too hard to see, of course, that if each leg, let's change up the color a little bit here, the legs are x, right? Because it's an isosceles right triangle. And again, don't forget these are 45s. This is why we call it 45, 45, 90. And the question is, how long is the hypotenuse, right? So if we take a look at the Pythagorean theorem, it's pretty quick to say that x squared plus x squared is equal to y squared, right? Well, that means that 2x squareds are equal to y squared, and that means that y is equal to square root of 2x squared, right? The whole thing is under the square root. Now, just simplifying that, remember, again, this is kind of going back into algebra, that's root 2 times root x squared. And since x is a positive number, we can change that to root 2 times x is equal to y, and typically we write that as x times root 2, just to make the point clear that the x is not under the square root. Okay, and so the hypotenuse of a 45, 45, 90 triangle is always x root 2 as long as the sides are x.